For question 1, classify each of the following pure substances as an element or a compound. To understand the answer to this question, I like to look at the flow chart for matter. Remember, matter is the stuff that things are made of. And we can divide it into two big categories: pure substances and mixtures. So this question has to do with the pure substances side. Now, to be a pure substance, you can only contain one type of matter. And there's two groups that we would classify as pure substances, and that would be elements and compounds. Now, one of the major differences between elements and compounds is that elements will only have one type of atom. So when I look at question 1, I can identify the elements by looking for things that only have one kind of atom present, where compounds have two or more different atoms. When elements bond together in a chemical reaction, that's how we form compounds. So let's answer the question number 1. So what I'm looking for is there only one kind of element, or are there two or more different types of atoms? So hydrogen peroxide. Looking at the formula, I see it contains both hydrogen and oxygen, so this would be a compound. Letter B, oxygen. Contains only oxygen atoms, which would be only one kind of atom, so I would classify this as an element. Remember, our elements are found on the periodic table. Mercury in a thermometer, Hg. So again, only one type of atom, so this would be considered an element. Mercury is element number 80 on the periodic table. And letter D, methane, a component of natural gas, is CH4, so it contains both carbons and hydrogens, so two or more different atoms combined, and so this would be a compound. So to answer question 1, it's important to understand the difference in the formulas between elements and compounds. Question 2. Classify each of the following as a pure substance or a mixture. So again, let's remind ourselves about the flow chart of matter, where matter is the stuff that things are made of. And we know that we can divide it into pure substances, which would be elements and compounds. And then we would have on the other side mixtures. Now, mixtures are when we take two or more pure substances and combine them together. It's not a reaction, and it's a physical change, meaning we just place the pure substances together to form mixtures. So let's see if we can determine, looking at the descriptions, if something's an element or a compound, which would be a pure substance, or if we have two or more substances together. So letter A, baking soda. Well, here's a formula. And so I see that this formula has sodium, hydrogens, carbons, and oxygens. So this formula represents a compound, and a compound would be a pure substance. A blueberry muffin, letter B. So a blueberry muffin has many components that are all sitting next to each other. It's not a specific compound. I couldn't write a formula for it. So a blueberry muffin would be considered a mixture. Ice, H2O. So there's a formula, and the formula contains hydrogens and oxygens. So a formula would represent a compound. Now that's not the answer to the question. The compound is a type of pure substance. Letter D, zinc. So here I just have Zn, the formula for zinc. Zinc is on the periodic table, and so this would, with only one kind of atom, is considered an element. And an element goes under the category of pure substance. And finally, I have trimix. And trimix contains 3 different gases, oxygens, nitrogen, and helium. And so 3 different things, pure substances, combined together give me a mixture. So to answer question 2, it does help to think about the flowchart of matter and to distinguish the differences between pure substances and mixtures. Question 3. Classify each of the following mixtures as homogeneous or heterogeneous. So mixtures can be homogeneous, and this one way to think of these descriptions is as something that we would see. And when something is a homogeneous mixture, to our eyes it looks uniform. So for example, if I had salt water, which I know contains salt and water, it looks like just one thing to my eyes when it's mixed. Heterogeneous would be a mixture where I could see the different parts of the mixture. So I would think of it as having distinct regions. For example, if I mix salt with pepper, I would be able to look at that mixture and still see the salt and the pepper. So letter A, non-fat milk. So I imagine milk, and when I look at milk, unless it's soured, I do not see different distinct regions. So this would be uniform, and it would be considered homogeneous. Letter B, chocolate chip ice cream. Well, right away I could see ice cream and I could see chocolate chips, so that I see distinct regions, and this would be heterogeneous. Gasoline. If you've ever seen gasoline, it looks uniform. It looks like there's just one substance there, but it's a mixture of a variety of hydrocarbons and other things. And so gasoline looks uniform, and it would be homogeneous. Cranberry juice. Cranberry juice also looks uniform, and so it is homogeneous. Again, remember, uniform means I cannot distinguish the different parts of the mixture. Tea with ice and lemon slices. Well, I could see the tea, I could see the ice cubes, and I could see the lemon slices. So I see distinct parts of the mixture, which would make this heterogeneous. So when asked to distinguish if something is homogeneous or heterogeneous, it's good to think about what it looks like. If it's uniform and you cannot distinguish the parts of the mixture, it's homogeneous. If you can see the different parts that make up the mixture, then that would be classified as heterogeneous.